So let's wait at least a couple of minutes just to give margin. It looks like a big crowd is here already.
So for those who just came in, there is a link in the chat pointing to the notes. It's useful to have the notes open because there are some links in there to specific documents you may want to follow. And you may also want to download the slides because there are links in those slides, but I hope they mostly are the same, so maybe you can just get by with the notes. And we are going to wait for 2 more minutes before we start. Okay.
Is it for pass for you?
Yes.
For me now, also. Okay, let's start. So welcome everyone to this interim meeting of the core working group. I'm Marco Tilka, my co-chairs are Jaime Jimenez and Kirsten Bormann. And as usual, the not well applies. So not well is not just about IPR, patents and so on. It's also and especially about our code of conduct. So please be nice with each other. And we've been recorded as usual. The agenda for today is about going the current status and open points for 2 documents from the CoreConf cluster, Young Seed and COMI, and then a number of points covered by documents in different working group related to different aspects of the Young and Core ecosystems that Karsten noted was proper to bring up. Any more topic you imagine to discuss today or any agenda bashing?
Agenda bashing is probably best when this agenda slide I prepared is up. So maybe we can switch slides.
Yep. So next is yours, I guess.
Yeah. Okay. So this is just my introductory slide to remind everyone where the core working group is on this work. We managed to publish a document that describes how to interchange Yang modeled information using CBOR, that's RFC 9254, and that's kind of the basis for the work that we will be doing today. And we have a number of other drafts in various stages of processing, and maybe the most important at this time, I will spend a large part of this meeting discussing SID allocation aspects, is the core SID draft that describes a process to actually get the numeric identifiers allocated that make Yang CBOR so efficient. And we will talk about this document, but we also will talk about Yang, the Yang allocations, the SID allocations for LPWAN, and Laurent has some slides for that. Then we have a draft that we haven't really updated in a while because we wanted to have the first two specifications out, called COMI, that actually tells us how to do the equivalent of RESTconf and using Yang CBOR and COAP. So this has been stable for a while, but there has been implementer feedback, and also there is a bug in the original specification in the version 11 that needed to be fixed. So we have generated a slightly simplified version, -12, and we should discuss whether this is done or should be reverted or should be made even more simplified. And finally, we should briefly talk about Yang library, which is the fourth document in the cluster, which probably has less of a problem, but yeah, we need to make sure it makes sense. Okay, so based on that, the agenda is focusing on SID allocation, and then COMI simplification or optimization, and then we go into the three areas: core Yang library, Yang models relevant to core, and binary Yang push. And I would like to do the SID allocation in about half the time, and or less, I hope, the COMI work in maybe a third of the second half, in 15 minutes, and then we have half an hour for what is under more here. So this is the kind of time schedule I have in mind. So any agenda bashing on this? Okay. So on SID allocation, we just submitted revision 20 of the core SID document, and we will talk about the LPWAN thing after we talk about SID, just as a reminder that we haven't forgotten that. And core SID is in a weird state right now because it's both in ISG processing and has a parallel working group class call running. So during the ISG processing, we did enough substantive changes that we thought it would be a good thing to do a working class call. And yes, it was a good thing because we got feedback, in particular from Yannick, that told us, well, there are some bugs in there and we have to work on that. And yeah, we think that revision -20 is dealing with Rob Wilton's discussed, but we are currently waiting on feedback from him. The thing we did was adding status information to SID files. So when the SID file just contains some draft assignments, we can make sure that the tools notice that and don't think this is the final allocation that will last forever. Okay, so let's talk about the oops. Yeah, the remaining problem that came up, and the other problems actually all stemmed from the fact that we don't really have a good tool to validate the example content and the SID file specification against each other. So we have done some manual fixes, but really we would like to have more support from the Python tool. So if anybody of you has some Python experience, maybe you want to think about helping us getting a version of Python that actually solves the problem that we are trying to solve. So the one thing that we aren't sure about yet is does the current version of Python actually generate a complete set of SIDs? And to answer this question, of course, we first need to understand what the complete set should be. This is the next slide. And then we probably should be evolving Python to emit this complete set. Of course, we can always do things manually, but we will make mistakes, more mistakes, I think, when we do this manually than when we have a tool doing that for us. So the first priority should be on getting Python to emit the full set. So if we leave something out, this is not catastrophic because new SIDs can always be added. But of course, it increases the workload on an implementer integrating several SID files for one module into their implementations, and we don't really want that. So let's try to strive for complete SID files. And the specific problem that Janne has pointed out is that we haven't really looked at RPCs and actions very much. And it came up because IETF system, the IETF system module that we are using as the example module here, actually does have RPCs. It doesn't have actions. So that is a problem. We probably also should have an example that has actions. But just looking at the RPCs, there are several RPCs here: set current date time, system restart, and system shutdown. And we only have SIDs for these identifiers here. So we have one for current date time, but not really one for current date time input. And it's also not quite clear that the set current date time is actually correct, because it might be necessary to include the input element into the instance identifier here. So this is kind of the first question we need to understand. Is this a change we need to make? And are we attaining completeness when we have done this change, or are we missing out on further examples of this problem? Do we have any other schema nodes that aren't captured by Python yet, but need to be in the SID file to be able to use the whole module over CoreConf? So that's really the first question we need to understand, and I would appreciate if people would air their view of this. So nobody has an opinion on this? Yeah, Andy points to a Yang issue, the Yang Siba issue.
That's just an old closed issue that I brought up a while back, that Yang does not generate all the SIDs for, in that specific example. Some actual nodes got left out. I think is your issue now, should input and output be added to the SID output? And I agree with that.
Okay. So we actually have to make this change. And this means this needs to be done to every RPC, both input and output, or how does this work?
Yeah, RPCs and actions, they implicitly have input and output.
Okay. We always have these 3 schema nodes, then the RPC itself, the input and the output. And then if these actually have leaves going in there or coming out of there, then we have further SIDs for that. Is that summary correct?
Yeah.
Good. Okay, what do the other Yang implementers in this call think about this?
I mean, my opinion is obvious, I think. I think the correct version would be what Andy just suggested. So everything should be both assigned as SID and be present in the SID file.
Right. Okay. So it would probably be
another case, which I didn't cover in my email. You can define an RPC or an action which has a leaf, for example, that has the same name in both the input and the output. So in order to differentiate between them, you need to insert this input that's now missing, or output. If this makes sense.
Well, I'm not a Yang expert, so this is really useful input.
So there's nothing preventing you from defining a leaf in both input and output with the same name.
Right.
If if you wish to differentiate between those things with a SID, because you have a mapping between an integer and a schema node identifier, you need to have 2 different schema node identifiers, and the only way to assure that is to actually use the schema node identifiers, which always implicitly contain input and output nodes.
Yeah, the what you see on the slide is actually from Yanei, so I just copied that from his email. Good. So I think that is answered. But of course, the question is, are we missing out on anything else? How do we find out if we are missing out on anything else? Okay, so maybe we can go ahead, Yanei.
So yeah, I think like Andy suggested in another mail in the same work group, all schema nodes should be mapped, because that's the only way to ensure I don't know, future proofness of this RFC. You never know if people will end up deciding to, for example, serialize a choice or case statement, which are both usually not instantiated in data instances. But if you map everything, you don't have that problem, and I think that would future-proof this proposal.
I agree. And one of the issues is that a Yang data store, which the Yang to CBOR, focuses on, is actually only conceptual data. It's only a representation of that data through protocol messages that is visible. So it's only protocol messages and artifacts that can use this encoding. The internals of a Yang data store are whatever they are. They're not, CBOR. So unless it doesn't even support the actual Yang protocols that are out there now, netconf and restconf. So that just numbering the various things will make it protocol agnostic, which would be good.
Do you have an
Yeah, I
example
agree.
for what parts of restconf, netconf are not supported?
Actually, restconf sends the input and output nodes.
Okay. Yeah, so we have to fix that. Good. Okay, so that was one answer I wanted to have. Then we have an example of a protocol that actually is important enough, interesting enough that we do want to run a manual allocation process. We're talking about running CoAP over millibit networks or LP-WANs. And so it's worth putting some time in there. And Laurent has prepared some slides. So I think I will stop presenting and Laurent can take over.
Do you hear me?
Yes.
Okay, perfect. So thank you, Carsten. So I will present what it's a personal presentation. We don't have discussed that right now at LP1 working group, but so in LP1 working group, we have designed a SHIC mechanism that allows to do compression, and it's based on rules. And now we are going to a standard format of the rules using a Yang data model. And of course, we have to represent it using CoreConf. And so the idea is to have something as small as possible, because we are using LP1 networks. We don't have a lot of bandwidth. So right now we have RFC that has been published, is 9363, that represents the Yang data model for SHIC rules. And if we can use Pyang to convert it into a seed file or with identities and data as it is encoded right now. And then we have a guard of some seeds that can be reserved for future evolution. So one other very important point that we have in for SHIC is that it has to be flexible, and we can have different people that develops new or extends basic Yang data model. And that's why, for example, we don't use enum for identity, but we use identity, because it's there is no conflict between them. So it means that in each model we create, we can have a lot of identities. So the problem is when we want to extend the basic Yang data model, so we will create somewhere else a new seed file that will use another range of seeds. And of course, when we will code the data, then we will have the delta encoding. And if the delta is too large, then instead of 1 byte, we will use 2 bytes or even 3 bytes or 5 bytes. So that's why we would like to propose something, another allocation mechanism that allows us to limit the size of the deltas in the CBOR coding. So for this example, I took a space that looks for me reasonable. It's 5,000. It looks to be free. And I took 500 seeds for that. And so the way we propose to do the allocation is not to have identity then data, then identities, then data, but to have two different blocks, one where we will have identities and one where we have data. So identity, we don't care that much because the value is stored in the data as is in the data in the data. So it's the size doesn't matter, but for data it's important to have as close as possible. So the idea to do that is to insert a gap of 23 value between each list seed, and then we fill these gaps with the lists that are the most important for the data models. So here we have an example of that. So here we have the seed allocation. So we don't start at the first value we have, but we go 23 value after, which means that we can use the minus to code some extension to the model. So here in the scheme, you have in blue the leaf IETF chic. I don't know if you can read it well. And then you have in blue on the left columns the negative deltas and the positive delta. So then we have in 5047 the next list. So we install a gap of 23 that overlaps the one from the blue one. So that's why we have also a column in green. And we have in 5070, we have the same thing for entry, where we have a gap of 23. Then we fill with the most important nodes. And one funny thing we discover, for example, that it's rule ID value and rule ID length that are something that you find in all the rules. If we use the regular Pyong allocation, since it's based on alphabetic order, so the delta will be higher than 23. So it's not optimal for each rule. We are losing 2 bytes for each rule for that. And after that, so we have all the information. And on the right hand side column, you have the identities that start at 5,300, which leave all the value between 0 and 250 for data. So here some arithmetics of what we have right now in the pipe for young data model for SHIC. So we have the basic one, so from RFC 9363. So it's 92 identity, 2 feature, and 42 data. And if we do, so what we have proposed here is to use 300 values for this for extendability, and identities start at 5,030. We have a draft on OAM, which will use 10 identity on 1 data, access control, etc. You have them on the picture. So that's where we have already this goal to do extensions. So that's what we. So I think that what we have to discuss in the LP1 working group is how we allocate this value, and for which leaf we say we can allow a very small delta, and for all the values that are not so used in the model, they can use the larger deltas. And for the process by itself, it doesn't change that much. It means that in that case, we will publish a seed file with all the leaves from the young data model, but here it will be done by manual allocation.
Thank you. So actually, I think the process in CORE-SID does not change at all because CORE-SID doesn't require you to actually use Pyong or any other tool. The important part is that you can get the range from IANA, and then you can fill in this range by whatever is best for the protocol that you are defining. So I think we are in a pretty good shape on the CORE-SID side. But yeah, it's really interesting what comes up when you want to do this properly. And my question was, how do we check this? So if somebody, or actually, how does a designated expert, for instance, check this? Now, the process doesn't require the designated expert to check every individual SID allocation because only ranges are being allocated, but it would be useful to have some form of service that checks this. And my hypothesis is that if we have a fixed version of Pyang that actually spits out all the schema nodes, we can write a very simple tool that just checks that version against the manually allocated version. They should essentially be the same, except that the actual SID numbers are different. So that should be an easy way to actually check this, and I think this should become standard practice if we actually manage to get a fixed version of Pyang or any other tool that does the dumping out of the schema nodes.
I agree. It was when I construct the Excel file, I put some macros to count how many entry I got to be sure that I didn't forget anything by changing the position of every node.
Question, I hope it doesn't cause any sidetracking, but this is being done for a specific protocol because it makes like var bind like retrieval better, because if you put gaps in and there's siblings in the request, the delta, you just made the delta larger because now there's all these gaps that wouldn't have been there. So
yes, but
right?
in CBOR you have some coding which means that if it's between -24 and +23, it's only 1 byte.
Yeah,
And then,
I'm aware of that.
yeah.
What I'm talking about is that the SID allocation, if depending on what's getting returned, the delta to the next table is now greater than it was going to be before, because it was only going to be about 4 SIDs away, and now it's 24 SIDs away. All right. So at least, unless none of the tables have keys or leaves. So it, you know, there's a trade-off. It isn't like all out, you know, that works in all kinds of retrievals. That keeps it down to 1 byte.
Yeah. So
what's really great about the current encoding, it's very clever, is because it is alphabetically sorted like that. It ends up that all children of the parent actually get allocated in that first 23, and there's almost no Yang models that have 23 or more than 23 child nodes of a parent. It's rare.
But in LP1 in SIG we have this we reach these numbers.
So you were showing things with 4 leaves in it. So the way Delta SID works, once you start the table, then you're going to be on the child nodes, and you're all the deltas from then on for that table will be like less than 23, almost, almost 95, 99% of the time. But I don't want to, for whatever, I don't think there's any problem with this. As Carson said, it's just manual allocation, and the validation is hard. It's really easy to just mess it up without a lot of automation tools that do the validation for you. But
Yeah.
you know, you're talking about if there's only 27 things to check, I think it can be done manually.
I think that's good input. In the end, of course, we need to construct a realistic example and simply measure which of the approaches of doing this actually helps most. And I think what Laurent is doing here is improving the locality at the lower levels of the tree, including future additions to that tree, which we don't know yet, at the cost of reducing the localities higher up in the tree. So it's a trade-off and depends a lot on how much you expect these lists to evolve, how much new things you expect to come in there over the lifetime of this SID assignment. Yeah, but it would be nice to have an example that actually is encoded based on these assignments, so we know how much better it is than what Piang does now.
I can try to provide one.
Because intuition is good, but raw data is better. Yeah, thank you. That was an interesting discussion. So
where I thought you were going was that you figured out, because in my implementation I figured this out as well, is the identities never show up in deltas, and so you really want them to be the smallest numbers possible because they always get encoded as their full value. So that's, you know, if you're looking for something to make it smaller, that's where you'd want to look.
I don't understand clearly what will be the process for getting seeds if we ask for a seed range for each young data model, or if the group is asking for a huge range or a big range, and then he will allocate it to all the documents it produce.
Now, this is a very good question that we should check whether we cover this in the CORE-SID document. Because I think we will always have families of related drafts that really should have a range that is managed by the people who are running this family.
I didn't bring this up before because it makes things more complicated, but for protocols that really care between 1 and 2 bytes, you really want a range that's down at the bottom that's just for what I call left-hand side. I mean right-hand side. Sorry, I got it backwards. So it's never used as a delta. So if the actual value was 6 million, that's what you'd put. So, but that would be more complicated, having like a range just for identities, and then you have to allocate a range from the identities and a range from the objects. So I don't think it should really go there. But obviously, the lower ranges need to be reserved for IoT, where the numbers stay small.
Yeah, I agree. But if we look at the range right now, we have the IETF range, which is on the 32 bits long or something like this. I don't remember. So
it's a million.
Yeah. So it means that we are almost on the same values or same size, because 1,000 has already been reserved for basic values. So if we come with Shake now, I think that a reasonable value is 5,000, and this is coded in 2 bytes.
Yeah, I think the observation here is that the whole IENA range for IETF is a million numbers, and of these, the first 60,000 are encoded in 2 bytes, and the next are encoded in 4 bytes. So if identity is important for you, then you really need to be in those 0 to 60,000, and that will be a little bit competitive space. But I think we can manage that. So, Laurent, can you look into the document and see whether what you're trying to do is covered by SID, and if not, send in a working group last call comment before the end of tomorrow?
Yes. Okay.
That would be nice. Thank you. Great. So that was a great discussion. Okay, so let me try to go ahead. We used 40 minutes of the 45 that I was hoping we were using. So the next thing is the COMI document that actually maps CoreConf to CoAP, like RC8040 maps RESTconf to HTTP. That already went to a working group last call 2 years ago. And then we got stuck on the Yang Sibor and CoreSID part, so we didn't discuss this further. But now with Yang Sibor done and CoreSID almost done, we discussed this at the IETF-115 hackathon. And we agreed that there is some complexity in this specification that actually isn't needed. And also there is a big bug in the way the encoding is done right now, and that bug needs to be fixed anyway, so that there is essentially no way to retain backwards compatibility with the -11 version into the future. So we looked at some simplifications. And what I want to find out is, are there concerns about these simplifications? So let me describe them. Yeah, so the slide is actually already asking the next question. Sorry. So just look on this slide, the example with /c/x9 question mark something. And this is the -12 representation of an instance identifier in the URI. So we know how to represent instance identifiers in CBOR payloads. There is an efficient binary representation. But since some of these representations need to be transported in URIs, we need to encode them somehow. And -11 had a almost full-page table of various cases that were used there, and unfortunately there also were bugs in there, as I said. So in -12 we simplified to simply say all the keys in that instance identifier, so everything after the first SID, goes into a CBOR sequence that is then base 64 encoded. So ZGV-OADA is just the base 64 encoding of a string key with a content E0. And the SID in the beginning actually gets its own place that doesn't go into a URI query, that goes into a URI path. And the 1533 is essentially base 64 encoded, but base 64 encoding is for byte strings. So we defined a numeric, an integer base 64 encoding that is essentially based on 6-bit digits, on 64, 0 to 63 digits. And 1533 turns out to be X9 in that encoding. So the whole path is X9, then a question mark, and of course, and then the rest of the key. And of course, in many cases, you won't have a key, so you don't even have a URI part. So if you want to get the entirety of 1533, you would just do a get on /c/x9. So this is what, go ahead, Ra.
I don't understand here. It's if 0 is so the 4 bytes are coded into 6 bytes or 6 characters. ETH0 becomes the ZGV0 the ADA.
Yeah. Well, actually,
So
it's more than that. It's not just the string ETH0, but it's also the information that this is a text string. It could be something else.
okay.
So the CBOR encoding of the ETH0 is 5 bytes. And then we divide the 5 by 3 and multiply by 4. And so we get the 7 bytes that we actually have to the right side of the question mark.
Okay, because for me, the get was something that human can read, and the fetch was something more for computers. And
Yeah,
here it's
that's definitely one downside of this. Okay, so this is what Dash 12 proposes, and the reason it has to propose that it has to propose a different encoding is that the old encoding couldn't cope with commas in the text strings, so that created problems. And this is fully data transparent, which I think is a good thing, and it simplifies implementation, of course, as well. So that's the Dash 12 proposal. The potential, Christian, go ahead.
Just to understand, so there is still get and fetch. What is the reason get is still there if it's already not compatible with the previous version?
The reason is that it was there before that. But yeah, that's a good question. So we could completely get rid of get, post, put, and do everything with fetch and patch, IPatch. Cool. That doesn't work. Kun, you sound like Mickey Mouse, and we cannot understand you. I'm sorry. Can you try your? Yeah, maybe you can type it. I haven't had a Mickey Mouse in a web conference for quite some time. That was great.
Better?
Much better.
Good, thanks. Usual microphone issues with too cheap webcam. Anyway, what I was trying to say is +1 to the to either dropping this or to dropping get, etc., or making them optional to implement.
Thanks. That's good input.
Good for this.
Okay, so that would make this slide number 10 kind of overtaken by events, because it essentially tells how to further simplify this by just doing the same thing you would do for a fetch, but just base it 64 encoding it in the UI and otherwise sending it as a fetch payload for the fetch. But I think that's a pretty useful input, that maybe we can just get rid of that complexity and streamline this. Good. Any other views on this? Okay, so I think we take that as the consensus of the room and go to the next, to be verified on the mailing list, as always, and go to the next item on the agenda, which is the core Yang library. So Yang comes with a Yang library model, which essentially allows a client to find out what models are available on a server and some specific properties of those. And when we started this work, Michel, who has defined many of the things that we're using today, came up with a simplified Yang library that is useful for constrained devices. So a constrained server, which is the normal situation here because we're trying to manage the constrained devices. A constrained server would use this form of a Yang library to announce its available models and so on. And this was done like 5 or 6 years ago. So it's probably a good idea to check which parts of the Yang ecosystem actually have changed enough that today you would use a somewhat different Yang library than the one you would have used 5 or 6 years ago. And one question is, are there any fundamental changes in which Yang libraries are used? But also, are there any small updates like the update we had to do to replace RESTconf data with SX structure and so on? So that's really a question to the Yang experts and to the people who know how that part of the ecosystem looks like. So Kuhn, I assume you haven't implemented the Yang library, do you?
Not the constraint version.
Can you say that again?
We did not implement the constraint version. No.
Right.
Just the typical Yang library that comes with netconf.
Okay.
But this pretty much looks, I'm looking at the document now, and it looks like it already supports NMDA. So I don't have any additional comments about that.
Okay, most likely we will do another working group last call on this document as well. Yeah, it would be good to get some indication of whether we have to redo a lot. And of course, the NIMDA stuff is was one of those major changes in the ecosystem that I was alluding to, and that is already in there. But I'm wondering whether there's anything else. So, for instance, for notifications. So, cool.
Looking through the draft now, so apologies if I'm missing something, skimming it. So from an implementation perspective, what would be very convenient for me is if I can fully implement this as, let's call it compile time data on the device and just throw it from the flash of my compiled binary back to the client and not have to ad hoc calculate these values. In practice, meaning that all the values here are fixed or depending on compile time information. And I think that's the case.
Yeah, it would be good to check that again with an actual constraint implementation and see what kind of Yang library it would spit out. But of course, ROMability of that information was an objective when we started this.
Yeah, well, I don't hear any shout from anybody else refuting this claim of mine, so sounds good.
Yeah, but let's make sure that we actually document this objective. I'm not sure whether the draft actually says that at the moment, and it should say that so that reviewers actually can start to scream if that is not the case.
Yeah, sounds good. Thanks.
Thanks for bringing this up. Okay, when we're done with Yang library, I wanted to bring up that there is a number of Yang models being created. Laurent already had one, showed one, or actually access control was part of his presentation. There is a Yang model being created for setting up state for the use of ad hoc and OSCORE together. There are likely going to be updates to 8824, the SHIC CoAP compression. And there has been a fresh submission of a Yang model for that, or actually it's in a pull request right now, I think. Obviously, we need to do these things to demonstrate that we are eating our own dog food. Some of these Yang models actually turn up both in constrained and non-constrained environments. So the data might actually come from a random netconf implementation that throws this into some system that then actually makes the constraint, the access to the constraint device to get the rule data or the connection configuration configured. So that's maybe one thing that's a little bit different from other cases we have had. But in the end, all of these actually need to work in the constraint space. And that's, of course, pretty much what the whole core thing is about, that not everything is constrained, but the protocols we are doing also need to work in a constrained environment. So one thing that we could try to examine is there anything we can learn from these Yang models that allows us to make CoreConf better still? And we just learned from LPWAN that alternative arrangements of the SIDs may be something that may be looked at without even having to change the standards, the specifications. And the other thing, of course, is then, are there any best practices that we can extract from these models? Or are there any other observations about this? So I plant this as a kind of an open mic on these models that are being created. So please go ahead. Laurent.
Yes, about the ad hoc OSCORE model, we use a binary type for keys. And if you look at something that is done for in I2 and FS group, is that they use X binary or X string, something, the type for a Yang type that has been defined to say this string is a hexadecimal value. But if we use it directly in CoreConf, we still have the string, and of course it's not optimal. So I don't know if it's it will be possible to say that X string will be automatically converted to binary in. And I think it's not a problem of compatibility, but it's more to have more compact model in the future.
Yeah, so we have had this discussion a lot. For instance, the standard datetime representation in Yang is very chatty. And I think that at some point we need something within the CoreConf architecture that helps us import modules that use very inefficient representations. But at this time, we don't have that. So we actually need to make sure that the models use something like binary, Yang binary, to represent things that need to be represented efficiently, like keys and hashes and things like that. So if you want to import a model that doesn't do that, well, you have to change it. I think that's where we are. Rafa.
That's the general comment. At least my feeling was, because I came from defining a jam model, but not taking into account the constraint part. But my feeling during the design of this jam data model was that I need to be very careful about the different types I'm going to use. And this is one of the examples, because Loren mentioned at the beginning we use X-string, but then we realized maybe that wasn't the right choice. And then we changed that to binary. But this is still okay. But what I feel is not like, okay, I define the jam data model as I want, because then the transformation to CBOR may have some implication. So that's something I learned during this process, you know.
So this is one of the answers to the last line of the slide. Best practices, we could tell model developers to actually work this way.
Yeah.
Okay.
One comment.
Yeah.
If the suggestion is to tell model developers to use the data type binary to make an opaque encoding of something else, that isn't going to fly with Yang doctors, I can tell you. And operationally, making the code work is sometimes difficult. And when you have no idea what you're looking at, and you have to trust the tools to tell you what you're looking at, it's harder. So that's, should be obvious.
Yeah, there is a tension here, because Yang right now doesn't allow you to build complex binary encodings, and we have learned that we sometimes have to do that. And for instance, CDDL has some support for nesting data into binary strings, like the .cbor control operator. So we cannot do this as easily in Yang as we can do that in CDDL. So I would expect that we will use binary for things that specifically are opaque by nature, like keys and hash values and things like that, and that we are not trying to come up with complex binary encodings that require additional code to look at them. I mean, looking at a hash is not really very useful anyway, so you might as well use binary. Looking at a key usually also isn't very useful in isolation. So I think that's the kind of use of binary we have in mind. But if we are importing a model that has a hex string for something, or that defines an IP address or a MAC address in the daytime in the chatty way Yang does, that may require you to actually do something. Oh.
My opinion, the model writer should write the model to make it as useful to humans as possible, and the protocol should figure out how to scrunch it on the wire. It's only on the wire that it matters, and and that's just a matter of protocols and designing protocols one way or another.
I think that that's a good basic rule that should be applied. It's just that we don't have that implemented yet. So we would have to change or extend Yang CBOR to have better support for that than we have today. And today you can just only define your own models that use binary in some way. Laura?
But I think since CBOR is typing what is sending, there is no ambiguity between if you are sending an X string or a binary value. So you can have some adaptation to do both.
No, I think, Andy, is not so much about the impossibility to implement this, but the fact that you actually need to debug this at some point. And the tools you have, I mean, we are just now getting a general CBOR dissector into what's it called? Wireshark. Tools need to learn to do these things, and life will be difficult for the time until they learn this. So having something in Yang CBOR or in another model that actually do this for you, take an existing chatty model and convert this into an efficient representation, that would be a good thing. But we don't have that. So that's a new development project.
Yeah, but what I don't understand is that if you put X string in your young data model, then when you convert it to RESTconf, you can use ASCII, and when you convert it to CoreConf, then you use binary. And that's something that is automatic. You don't have, when you design your model, you don't have to know how it will be coded after. It's not your problem at that time.
Yeah, so we actually even have a CBOR tag for that, specifically for hex strings. So it's like 27 or something in that range, not 27, 23, that you can use to actually say, here's something that really should be a hex string, but that is too inefficient. So here is the binary value. And when you get that, please unpack that again. But we haven't used that in Yang CBOR at this point in time. So we would have to make an extension to Yang CBOR to allow the use of this tag to make this particular optimization. Then, of course, you want to do the same thing for MAC addresses and IP addresses and datetimes and a few other pieces of data. So that's the development project I was talking about.
Okay, yeah, agree.
Good. So what I would really like to see is a little bit of information about applications that actually want to use models apart from existing models that use something like hexstring or datetime or whatever, and really understand what damage the fact that we don't have support for that actually is causing us, and then we can better understand how we should address this. So this would be a general question to the working group. Yeah, and Raphael points out on the chat that if you really need to optimize things, then you have to do custom stuff. So we are looking for something that covers the 80% part. Christian.
So there is the comparatively simple aspect of doing the encoding on the CBOR side. There's a much harder aspect of knowing when to do that encoding. Will the Yang models need additional information to know that, say, something is not only a string, but it's really a string that contains an IP address and thus should use tag 54, but none of the other encodings that could also do this. So like some application, if we introduce these compression mechanisms through CBOR, then it has to be agreed on which of them can be used.
Yeah, there are two ways of doing that. One is that this is completely deterministic. So each time you use a datetime, you actually compress this down to a CBOR time tag or something like that. The other way to do this is to say, this is a general compression mechanism. So if somebody has a home address that looks like a datetime, we will compress this home address as if it were a datetime. Well, if you want to do this efficiently, then maybe you can look into your model, your Yang model, and see whether it's worth trying to do that. So those are very different ways of doing this, and deciding between the two is maybe part of that project I was talking about. Wow.
One generic comment is, I think we have the same problem with XML and JSON, and because in XML everything is ASCII, in JSON you have number and ASCII, so when you do, you always have a problem to do a conversion. So it's so in CBOR you have something. I had some problem, for example, for checking some data model when I was putting union in a type def instead of in a container, because the tool were not going that far to say, oh, this is a string, and they believe this is a number, and they believe it was a string, and of course the model was not correct, and so we this is a very huge problem for every representation, not only for CoreConf, for CBOR.
Yeah, the way unions are handled in Yang is extremely problematic. And we have a number of workarounds in Yang CBOR that I would say have increased the complexity of Yang CBOR by like 50%. So that's not something we can change. But normally, if you have some JSON and turn it into CBOR, you have a big problem. But if you have a model like the Yang model, you have a significantly smaller problem, because the model tells you what you should be doing with these data. So we are in a relatively good place converting JSON data into CBOR data here, but we don't have everything, and that's what I meant. We have to run a little project to possibly make this happen. Andy?
I found that CBOR has more fidelity, more information that it's putting on the wire than either JSON or XML, and it's like you can do extra validation that you can't, because you know the Yang, you know, and the CBOR tagging is more specific than Yang JSON. So it's actually I think the encoding, I want to get rid of XML in netconf and just use CBOR. But the working group probably isn't ready for that, so it'll take a while. But you know, it's much better encoding than what we've been using for a lot of techie reasons that's related to TLVs versus content analysis. Any kind of encoding where you have to like scrub the content is worse than CBOR. The TLV approach is much better if it's right. As soon as the TLV is wrong, then the whole message is toast. That's its one downside. But if it's right, it's much more efficient and even more accurate than the other two.
Yeah, and I think that's something that constrained implementers for constrained environments really like, that they don't have to do all this guessing and so on. Okay, so I have one more slide before we come to the bring your own issue section. There are two documents that have been pointed out that are about binary Yang push. There is the UDP notification document, which is the NetConf working group document. And there is also an interesting Yang model that might be helping with doing notifications. So let's talk about UDP notif first. Yeah, that's what you get if you design something like this and don't know about CoAP. And
I will note that I suggested that we use CoAP as the transport for binary Yang push, and the NetConf working group was, no, we don't have to solve any of those problems that CoAP had to worry about. We'll just do this. Oh, really? Okay. It's to call it seriously weird. I thought it was just kind of bad. It's really not a binary protocol at all, as you point out. Yeah. I don't know that it's much of a protocol at all, other than it's just here's something we're stuffing in a UDP frame.
yeah. Well, CoAP can do that too. I mean, we have non-confirmable messages, so that's certainly some way of doing this. So maybe we should just sit down and write a core working group draft on how to do this. The one thing that I'm not sure we can solve is the congestion control issue, and this specification simply says, oh, don't use this where you might have congestion, which of course means
in the old days, the IETF didn't let you get away with that. Now maybe they do. I don't know.
Well, we have a whole new working group for congestion control in the IETF. So yeah, I think some discussion is needed on this, and I don't know how much transport area people actually have worked with this. So how implemented is this specification?
I don't know that that anyone but the authors. I think there is actually some open source implementation started. I only brought these up because, and actually the second draft creates a little structure, so that actually gives us a way to assign the SIDs. That was the thing missing before, and we were talking about needing some complex special case solution in CBOR, but we don't. We just need that struct, and so I think actually, the NetConf working group needs to move the ball on this. Really, there's probably nothing that this working group needs to change now that those structures are supported. That was the change needed, and it's done.
Mm-hmm.
So we're probably good on this. It's not really an issue. It's more for the NetConf working group to actually get this stuff done.
Yep.
So yeah.
Yeah, but I think we should be aware of this going on and maybe think about it as a potential application for CoAP, even if it's not specified that way right now, but we should be able to do similar things in other environments. Okay. So we actually have used 80 of 90 minutes now. And I have a last slide. So anything else that is on your mind with respect to CoreConf, Yang, CoAP, CBOR that we could discuss in the last 10 minutes? Laurent. Oh,
I actually have. I don't think that this is in scope, but it's really looking perplexing to me how all of the published IETF modules will get SID files. If it's one at a time, it's it's not going to work, and it's take years, and no one's going to want to do that. So I guess that's also up to the NetConf working group, because core working group has this a set of like 11 modules that are going to get numbered. So the other 300 or so published ones in the IETF, I think that's a discussion that needs to happen at some point.
Yeah. So I hope to address this in conjunction with yancatalog.org, because they are set up to make this happen. But it's not something we actually got to yet.
Yeah, okay. I figured that at some point someone's just going to generate a bunch of SID files and say, here, use these.
Yep.
But it's sort of like that kind of step needs to happen. Okay, that was my only issue there.
Yeah, good point. Laurent?
Yes, just because it's the end of the session, but to talk of hack we do with Alex Fernandez, it's because now it's with a SID file, it's easy to go from JSON to CBOR, but in the other direction, it's quite complex, because when you have a hint in CBOR, you don't know if it's a hint, if it's a int, if it's an enum, or if it's an identifier. So you need to know the type. So one way is to go to the Young data model to look at it, but it means that you need to parse Young, and it becomes quite complex. So with Alex, we did a hack on Pyong, and it's available in my GitHub repo, and it adds in the SID file the type that it has been extracted from the Young data model. And this way you can do the conversion in both directions. And for example, for Chic, it's very useful because you are manipulating core conf. And when you want to validate your model, then you can change it to RESTconf, and then you can use tools like Youngson to validate it. And we had also another a map with list seeds and the keys that are related to that list. And this allows the automatic process, or to parse a young tree without knowing what you have inside. So Alex will release an implementation to manipulate core-conf tree, I think. And so if you can have a look to this this hack to Pyong, to discuss if it's something good or not.
Wow. Alex, you wanted to say something?
Yes, can you hear me?
Yes.
Cool. So hi everyone, just my master students here in IMT Atlantic with Laurent. And yeah, I was working with Rafa also on this ad hoc and Oscar project. I was doing this called it PyCoreConf library, which helps doing this conversion like really easily from either XML or JSON to CoreConf, and then back to getting a Python dictionary. And just to make the point here that with Laurent's fork of Pyong, getting the correct types was super important, and it was very helpful and made things so much easier.
Great. I think I will look at this very soon. And now, of course, I also know who will actually hack Pyong to spit out all the similar identifiers.
I don't know how I succeed to do it.
Great. Anything else? I think Marco wanted to say a few words about meeting planning.
Yes, most that. But first of all, thank you very much for the great discussion today. And this is the last interim before IETF 116, where we meet for 2 hours on Tuesday, 28th. So we hope to see you all there online or on site. We plan otherwise to resume with the interim meetings second half of April, and we thought tentatively of April 26, to keep the same cadence and time every other Wednesday. So we'll sync with CBOR as usual and confirm on the mailing list, hopefully already during the IETF week. So any further AOB? If none, thanks again. Thank you very much, Christian, for the minutes. Have a good day. See you at IETF 116.
Don't miss the link that Lars just sent in the chat.
Thanks.
Thank you. Bye.
Thank you all.
Bye-bye.